All right, so for today, this first section of notes has a single fraction, it has multiplying, and it has dividing in it. We are going to just do a single fraction and multiplying today. Tomorrow we'll kind of recap both of those and do dividing. So like notice we're on 8-4. We kind of jumped in the middle of this chapter. We're only going to do 8-4, 8-5, 8-6. Just those three sections. So, but we're going to spend probably at least 2 days on every section just because there's a lot in them. All right, so you guys ready to go? You ready for this? Exciting. All right, yeah, aren't those pretty? Those are pretty. So, these are called rational expressions. Why is it called an expression and not an equation? There's no equal sign. There's no equal sign. So we are starting out with just expressions. So there's no equal sign. We are not solving. But as you know in math, we need to simplify. So we're going to start with just a single fraction, and we're going to work on how do you simplify these things. Okay? So they can look, here's some options of what they can look like. But can you see, like, we can do some factoring here. You can do some factoring up there. So, like, there's a lot of factoring that goes on. And all the ways of factoring that we've seen, they all come back again. So you may see regular old factoring, GCS, difference of squares. You can see grouping. You can see cubes. It all comes back. So in a simplified rational expression, the numerator and denominator have no common factors other than plus or minus 1. So in other words, if we can cancel something out or cross it out, we're going to do that. So if I have AC over BC, what could I cancel out? The C's would cancel. Right? So that cancels, so it's just A over B. Now, the hard part is looking up here, things don't cancel piece by piece like we did here if there's a plus or a minus sign involved. Okay? If it's held with multiplication, we can kind of piece those out one part at a time and just kind of cancel things out. If there's a plus or a minus attaching them together, that's a whole group. The only thing I could possibly do is factor it. And then in order to cancel, it'd have to be exactly the same on the top as exactly the same on the bottom. And we'll get lots and lots of practice with that. So some examples for you of not simplified versus simplified. So this first one, notice they're both factored. I have an x minus 2 on top and an x minus 2 on the bottom, so those are going to cancel. But if I look at the simplified answer, notice they did not cancel the x's. I didn't cancel the 3's. Stop and think for a minute. If I would cancel that, cancel the x's, cancel the 3's, so you're telling me the answer is plus over minus? Does that make sense? That doesn't make sense. So if this held with a plus or minus, that's like the glue that holds them together, I can't touch this. Plus or minus, they do not cancel out piece by piece. That is as simple as that one gets. Down here, notice it's exactly the same on top, exactly the same on the bottom. Therefore, the entire things cancel each other, not piece by piece, the whole plus thing. And then if everything cancels, it's not nothing, it's 1. Because stop and think, if I would show you like 5 over 5, what's that? It's 1. 5 divided by 5 is 1. But if I can't, I'm like, all right, they both cancel. Yep, it's nothing. No. If I have 5 cookies and there's 5 of you, you each get 1. Once I eat them all, then you get nothing. All right. And then down here, do you notice there's no plus or no minuses? No plus, no minus? You can just kind of piece by piece take it apart then. So here, I can cancel this x with one of these, right? So there's like x to the first left over. And then 4 and 8 can both be divided by 4. So the 4 divided by 4 is 8 divided by 4 is 2. So I have 1x over 2. So just x over 2. So no plus or minus, piece by piece. You cancel things out. If it's held with the plus or minus, you cannot. That's the biggest, hardest thing with this whole chapter. If it's held with a plus or a minus, don't piece that thing out. Okay? All right, so we're going to talk about restrictions. Now, students always wonder, like, why are we talking about this now? I'm teaching this to you now so that when we get to solving, this is second nature by that point. Okay? Right now, like, it really doesn't matter by what we're doing that you tell me this, but when we get into solving, it makes a huge difference. So a rational expression in its simplified form must have the same domain in order to be equivalent. Do you guys know what domain stands for? Domain stands for all of the possible answers for x. That's all your possible answers, okay? Now, I'm not solving yet. So that's why it's like we're talking about possible answers in the future, but we can't actually solve it yet. Just Siri? So the domain will include all real numbers. So all possible real answers are out there, except for numbers that make the denominator equal what? What's your denominator not allowed to equal? 0. So if you have something that you would say is an answer and it would end up plugging in the bottom, make a 0 down there, is no good. Okay, that can't happen. Numbers that make the denominator equal 0 can be referred to as restrictions. And when we get into solving, those are like no solutions, right? Those are answers that don't actually work. So looking here, if I have this fraction, do I care if the top would be a 0? I don't care. That's okay. The bottom can't. You're not allowed to divide by 0. So what would x equal here? If I asked you to just solve, what's x equal? 3. And what's x equal here? So this is what x cannot be. Because what if I have 3 for an answer? 3 minus 3 is 0. That puts a 0 in the denominator. That's not okay. If I put a 2 in, 2 minus 2 is 0. It puts a 0 in the bottom. I can't have that. So to figure out your restrictions, you just set your denominators equal to 0 and solve them. Those are what x cannot be. So what can x not equal here? 0. Right? Set them equal to 0. 8x equals 0. Okay, I'll divide. X cannot be 0 then. So to find restrictions, maybe make a note here. To find restrictions, set the denominator equal to 0 and solve. These are your restrictions. And again, I'm just trying to get you to used to this now, so when we get into solving, it's second nature at that point, and you can just focus on the solving, not the restriction part. Yes? So to find restrictions, we just set them equal to 0 and solve. So are you okay with where I got 3 and 2 from? Okay, so it's a restriction, because if I would tell you answer, say we're into solving, and you're like, yeah, x equals 3. That's my answer. And I'm like, well, hold on. If I plug that back in, 3 minus 3 is 0. 3 minus 2 is 1. What's 0 times 1? It's 0. And it puts a whole 0 down in the bottom. Have you guys ever asked Siri what 0 divided by 0 is? Yeah. If you've never heard it, hold on. We got to do it because it is really funny. Hey, Siri. What is 0 divided by 0?
Imagine that you have 0 cookies, and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
Aww. Man, Siri's mean. Really funny, though. All right, so we are going to start with just a single fraction. So if you look at your green paper, you have one fraction as the first little column. Here is your step-by-step how I want you to do this. Okay, I'm trying to break this down to keep it nice and simple for you. So first, you will factor anything and everything you can. Then you will do your restrictions. So how do I do restrictions? Set denominator equal to 0. No, you cannot write that on your green paper. Nope. By the time I get through this chapter, restrictions become like second nature. You don't, seriously. Trust me. You won't even have to, you'll know how to do it. And then cancel. Cancel, right, any top and any bottom together, right? All right, so number 1, 15x squared over 20x to the 5th. Can I kind of look at these one piece at a time and cancel? Or are there things holding it together that I can't touch it? What holds it together that I can't take it apart? A plus and a minus sign. So no plus minus, I can do this one piece at a time. No plus minus sign holding these together, one thing at a time. Here, do you see how there's plus and minuses? I can't be canceling out these x squareds because they're held with a plus or a minus sign. So this one I can factor, but I can't cancel just sitting it, like this sitting here. I can't cancel these x's here. I can't do that. No plus minus sign holding this together. So I can take out part anything I want. So what can I cancel in number 1? 5? Okay, so let's just kind of take one piece at a time. You're right. So he's looking at 15 and 20 can both be divided by 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. Okay, what about the x's? How many x's can I cancel? 2. Right, I can cancel the 2 from the top. How many would be left on the bottom? There'd be 3 left. Now, this chapter gets to be a mess because we cancel things, we write over it, we cross stuff out. And I'll be honest, the hardest part of this chapter when it comes to this is reading your own handwriting. I've had a lot of students who are doing it all perfect when they go to write their final answer. They just totally don't see a piece they have written there because their handwriting's bad. Okay, so on the top I have left is 3. The bottom I have a 4x cubed. What were my restrictions? What is x not allowed to equal? 0. Because look at the bottom. It was 20 times x to the 5th. Well, if it's just being multiplied by 20, it's the only thing that's going to make that a 0. If I multiply it by 0. It's kind of like a baby brother, right? The 20x to the 5th sitting here was like baby brother, bless you, out front, which gives you a 0 for an answer. So my restrictions are 0, and that is the simplified answer. It's as simplified as I can get. All right, number 2. So step 1 is to factor, but if there's no pluses or minuses, do I factor anything? I don't factor it. Step 2 is my restrictions. Notice in the denominator I have an x and a y. X and y, neither one can equal what? 0. Again, they're just being multiplied. The only thing that's going to make that bottom a 0 is if x or y is 0. What can I cancel? 2 y's. Okay, so cancel out the 2 y's on top. How many's left on the bottom? There'd be 1 left, right? There was 3. If I cancel 2 of them out, there's 1 of them left. What else? Okay, x's. So I cancel the 2 x's from the bottom, and there'd be 1 left on top. How about the 24 and the negative 6? I can divide them both by negative 6. So 24 divided by negative 6 is negative 4, and negative 6 divided by negative 6, just 1. Who said 0? Just 1. So what do you got left on top? Negative 4x over y. That's as simplified as I can get. I would take that. Just typically, like, if you get used to like using your calculators, it doesn't like negatives in the denominator. So typically we move them up to the top, but it's not wrong. Number 3, step 1 says to factor. How does the top factor? 2 and 4. All right, we have x and x, plus minus, options for C, 1 and 8 or 2 and 4. 2 and 4. So a positive 4 and a minus 2. How does the bottom factor? Now, the bottom, this is the dreaded 6-5 combo. You will hear me reference this a lot because people mess this up all the time. The dreaded 6-5 combo. That's what this is. Because if I'm looking at this, what are my signs? We'll start there. They're both negative. I know x and x. The reason it's the dreaded 6-5 combo, your options for 6 are 1 and 6 or 2 and 3. Is it possible, just looking at my numbers, that both of those options could make a 5? Yeah. So what happens is we get in a hurry and we're like, oh yeah, and you just kind of throw down 1 and 6, or you throw down 2 and 3, and you forget to look at your signs. Because it doesn't both make a 5 if they're both minus. Which one should it be? 2 and 3. Okay, so you just got to be really careful. When you see that 6 and 5 combo in there like that, people mess it up all the time because they get going too fast and they don't look at their signs. All right, so that was step 1, which is a factor. Step 2, Restrictions. Set your denominators equal to 0. So what can x not equal? 2 and 3. Right? 2 and 3. If I would solve those, that's where I would get 2 and 3. Those are my restrictions. Does anything cancel? Yeah, what cancels? X minus 2 and x minus 2. Good. So on top I have x plus 4. And on the bottom, x minus 3. Can I cancel these x's? Why not? They're attached with the plus or minus. You can't touch them. Okay? That is the hardest thing here in the beginning for you people to get their head wrapped around. If it's held with a plus or a minus sign to something else, you cannot just take it apart. I can factor, but I can't cancel it. Question so far? All right, number 4. Step 1, factor. Does the top factor? How's the top factor? Good, x plus 1, x plus 4. Those of you who are good at factoring, you probably like this chapter. Those of you that stink at factoring, are really slow, you're not going to like this chapter. How's the bottom factor? Good, x plus 4, x minus 4. So that was step 1. What's step 2? What's step 2? Restrictions. Yeah, you know that green paper I put in front of you? What did I say to do with that? Read it. Read it. All right, what can x not equal? Set your denominator equal to 0 and solve. 4 and negative 4, so plus or minus 4. Set your denominators equal to 0 and solve. Because I can't divide by 0. So if I would say that x equals 4, you plug that back in. 4 minus 4 is 0. 4 plus 4 is 8. 8 times 0 is 0. I'd put a 0 in the bottom, and I can't do that. Yep, that's why I wrote it down. Set denominators equal to 0 and solve. That's your restrictions. Yes. All right, so from here, last step after restrictions is cancel. The x plus 4s. So I have x plus 1 on the top, x minus 4 on the bottom. Can I cancel the x's? Why not? I said so. They're held with a plus or minus. I cannot. All right. Number 5. Anybody have a problem with how number 5 is set up? I heard somebody say it. The 4x. That says 12 minus 4x. Is that standard form? No. We need to always write them in standard form. So this should be negative 4x plus 12. So if at any point, guys, when you look at a problem, if it is not in standard form, you need to rewrite it in standard form. All right, so now here we go. Step 1 says to factor. How do you factor the top? Oh, we do. The most basic factoring there is. GCF, what can I take out? Negative 4. If I take out a negative 4, what do we have left? Good, x minus 3. How does the bottom factor? Good, x plus 3, x minus 3. That was step 1, which was factor. Step 2, what can x not equal? Good, plus or minus 3. Setting your denominators equal to 0. It's only the denominator. I don't care. Top can be whatever it wants to be. Denominator cannot be a 0. 3 or negative 3 plugged in would make a 0 on the bottom. All right, last step is to cancel. X minus 3. So then on top, I have negative 4. And on the bottom, I have x plus 3. You can put the parentheses around it or not. It doesn't matter. Number 6. Anything stand out to you about the way that one's written to start with? Look at it carefully. Hold on. Yes, you have like terms sitting on the bottom. Guys, look at the bottom here. These are like terms. So, yeah, let's do it this way. I'm a lazy mathematician. So, like terms here, that's going to make that 15x squared plus 9x on the bottom. Okay, you have like terms there. Okay, step 1, factor. How do you factor the top? Don't say you don't. Greatest common factor. Guys, look for that. All right, greatest common factor, which is 3x squared. So that would leave us with 3x plus 2. The bottom, I can take out a 3x. And I'm left with 5x plus 3. Step 2 is what? Restrictions. What can x not equal? Set your denominator equal to 0. So what about this one? That's a 0. And this one? Negative 3/5. So there's my restrictions. So x cannot equal. Does anything cancel? Yes. This 3 and these x's, are they attached with a plus or a minus sign? No. So I can cancel this 3 with this 3. I can cancel this x with one of these. Now, can I cancel into here? No. These are held with a plus or a minus. I can't touch them. These are not. I can take those one piece at a time. So on the top, I have an x and a 3x plus 2. And on the bottom, I just have 5x plus 3. Ooh, can I cancel these x's? No. That one's held with a plus sign to that one. That's right. Read your paper. All right. Questions so far on just a single fraction, how to handle that. Sweet. All right. So now that we did a single fraction, we're going to, actually it's 1220. 1220 is B lunch, yeah. So we're going to move into multiplying, which is really not too bad. Your steps, factor, restrictions, cancel. Those are all the same. And then a very technical term for step 4, smoosh. It's just really fun to say, isn't it? Everybody say it. Smoosh. You make a weird look when you say it. Smoosh. Smoosh. Look like you're kissing somebody. Smoosh. Now, the reason I say smoosh is because I don't necessarily always want you to multiply everything together. Like if I have an x plus 2 and an x plus 3, don't distribute those together. No. Answers can stay in factored form. Now, if I have a 2 and a 4, I wouldn't smoosh those as 24. I would actually multiply the 2 and 4 then. Okay, but I say smoosh because I don't want you to think you have to multiply every time. That's why I say that. Smoosh. All right, so here we go. So step 1, factor. So notice now I have 2 tops and 2 bottoms. Okay, so I'm going to just factor everything I can. So the first top, how's that one factor? Sorry, it copied kind of cloudy. Oh, good. So we're going to have x plus 3 and x minus 2. How about the bottom? It's just 2x squared. Okay. Top of the next one, how do you factor that one? GCF, which is 2. Take out a 2. So I have x plus 4. And the bottom, that's regular factoring, both plus. Good, x and x, and 3 and 4. So multiplying, still the same steps, but there's just more to factor, right? There's more parts, there's more pieces. Questions so far? All right. So step 2, restrictions. What can x not equal? Very nice. So I have more than one denominator. So I still set my denominators equal to 0 and solve. So this is a 0. Do I need to write 0 twice? Now, if I asked you for the answers, 0 would be twice. Now, do I have to say it twice for what it cannot equal? No, I don't have to. Right. And then -3 and -4. If you want to tell me twice that x cannot be 0, okay, fine. That's okay. You can tell me twice. Just like I tell you guys numerous times what to do or what not to do, right? What? Right? It's like I tell my children, you know, do not, whatever. I have to tell them lots of times for them to understand me. And then they still do it. All right. So I factored. I did restrictions. What's step 3? Cancel. Read your paper. It's cancel. Now, guys, I can do any top, any bottom. Yeah, any top, any bottom. So what cancels? X plus what? 4. Good. X plus 4s. What else? X plus 3. And the 2. Not held with the plus or minus, not held with the plus or minus. So I can cancel that 2 with this 2. Okay, what do you got left on top? What do you got left on bottom? Ooh, can I cancel these x's? No, that one's held with the minus sign. Can't touch that one. And I am done. Now, one of the things I'm going to have to try to draw your attention to, okay? Because like the last chapter, remember we talked about if it's an x cubed, you want to make sure you had 3 answers, right? That little mental check. We did a lot of those for the last chapter. Same thing here. Once you think you've canceled everything and you write your final answer, double check. Make sure there's still not something sitting there that you could cancel. Maybe you just missed it from the beginning. Okay, so just kind of do a little mental check there. All right, number 2. Step 1, factor. How's the top factor? X plus 3, x minus 3. Good, that's just an x. I can't do anything with that. How about the top? 3x. And the bottom? So factor? Take out a 6. So I have x plus 3. Got to train your brains, guys. We need to make sure we're looking for that GCF. Those show up a whole lot. All right, so step 1 was factor. What's step 2? Restrictions. X cannot equal. Look at the bottoms. What can x not equal? 0. Does baby brother give me an answer? Nope. And -3. Those are my restrictions. All right, does anything cancel? Any top, any bottom? X plus 3. Yes. Is it held with a plus or minus? Nope. So that means I can take it. This x and this x. Good. 3 and 6 can both be divided by 3 divided by 3 is 1. 6 divided by 3 is 2. 1/2. Yeah, 3 over 6 is 1/2. All right, on the top, what do we got left? I have x minus 3. Do I need this 1? No. And on the bottom? Just 2. Yay. Number 3. Oh, it's a pretty one, isn't it? What's step 1? What's step 1? Factor. Go ahead and factor. Try this one on your own, guys. Yeah. All right, guys, so step 1 is to factor. So a 2 comes out of the first one, and x minus 4. The bottom is a difference of squares, bless you, x plus 4, x minus 4. The top is x plus 4 and x plus 1. And the bottom would be x plus 4 and x plus 4. All right, so that should have been your factor. Next step, restrictions. What can x not equal? Good, just plus or minus 4. If you want to tell me numerous times, you can. But I get a -4, +4, -4, -4. So plus or minus 4. Canceling. And I think this is where a lot of you are having the same question. When you cancel, think about how you're canceling things. Where are they located? Top and bottom. That's what cancels, not next to each other, right? So if I'm looking at top and a bottom, I have x plus 4 and x plus 4. I have an x minus 4 and an x minus 4. This x plus 4 and this one over here? No, they're both on the bottom. To cancel, it has to be one top, one bottom. Doesn't matter what fraction it comes from, but just one top, one bottom. So looking at what I have left, I have a 2, and I have an x plus 1, In the bottom, I have x plus 4 and x plus 4, or x plus 4 squared. Now, this is why I write smoosh, not multiply, because I don't want you to multiply that back together. Be happy. I'm not asking you to multiply that back together. So you're just going to kind of smoosh together everything that you got left, and that's where we're at. That's as simple as it gets. How'd we do? Okay. All right, number 4. All right. Oh, that cute little penguin. Isn't he cute? All right, number 4. What's your first step? Factor. How's the top factor? Good. X minus 1 and x minus 2. The bottom? That's just x plus 2. I can't do anything with that. How about the top? I'm glad one person talks to me. And the bottom, ooh, it's a 6-5 combo. 2 and 3 or 1 and 6. What are my signs? One's plus, one's minus. So it's got to be a 6 and a 1. Plus 6 minus 1. Right, because that last one's negative, so your signs have to be opposite. So it's got to be 6 and 1, not 2 and 3. What's step 2? Read your paper. What's step 2? Restrictions. X cannot equal 1, negative 6, and negative 2. Good. All your denominators, right? Negative 2, negative 6, and 1. Order doesn't matter. Just again, all your denominators, you're setting them equal to 0 and solving for your restrictions. And then, fun part. Anything cancel? X plus 6. Good. X minus 1s. And that's it. What's step 4? Smoosh. Smoosh it all together. On the top, we have an x minus 2 and an x minus 6. And on the bottom, we have an x plus 2. Smooshed it all together, and that's what we got. Smoosh. Yay. You all right? You good? Nope, we got 2 to go. But wait, there's more. Put it under 1? Over 1. Good. All right, we had a bit of worry whether it was under 1 or over 1. Is it under or over 1? Where do you want to put the 1? Under it. So you were putting this over 1. Over 1. But wait. I don't like that. Why don't I like that? I don't care about that. It's not in standard form. There it is. This is negative 10x plus 15. Be careful of your signs when you rearrange them. Whatever sign's in front, it stays with it when you rearrange it. Okay, so just be careful of that. All right, so there wasn't a fraction. Just put it over 1. Over 1, not under 1. Right? Make sure it's in standard form, and then we factor. So a 4 on top. Ooh, how's that bottom factor? What are my signs? Plus, minus. Options for A? 2 and 1, so 2x and 1x. 1 and 3 or 3 and 1? 3 and 1. That gives me a positive 1x, so my signs are backwards. Oh yeah, remember all those, factoring rules? We got to check our answers, all that stuff? Yeah, we're still doing it. You're in big trouble if you don't remember that. I have failed you as your teacher if we cannot factor at this point. All right, top of the next one, how do you factor that one? Negative 5. What do you got left? 2x minus 3. What? Oh, yeah. All right. Step 2, restrictions. What can x not equal? Good. 3 over 2 and negative 1. Step 3, cancel. 2x minus 3. Oh, that's it. All right. Step 4, smoosh. Now be very careful when I smoosh. Negative 20. Don't smoosh that together and give me 4 minus 5. You laugh. There's going to be people in here going to do that. Danny already did. You see that dot? What does that dot stand for? Multiply. 4 times negative 5 is negative 20. And on the bottom, we have an x plus 1. All right, so guys, I have smoosh on there on your step-by-step because I don't want you to distribute and all of that stuff. But if you have just plain old numbers, please multiply them. Don't add them. Don't subtract them. That is a multiplication problem. All right, one more problem, guys. One more. What do you mean no? Very nice. He's like, put it, what word do I want? Next to? Beside? Try this one on your own, guys. All right, guys. So working through this one, don't forget GCFs, right? They show up a lot. So the first one has a GCF of 3x, and you're left with x plus 1. The bottom is just 1. This one I can take out a 2, so 3x plus 1. On the bottom, we're going to have 3x and x, 1 and 1, and they're both plus. So what were your restrictions? X can't be what? Negative 1/3 and negative 1. Did anything cancel? Yeah? X plus 1, 3x plus 1. So what did you have left? Do I have 3x plus 2 left over? What's a dot mean? It means to multiply. So 3x times 2 is 6x. If you have 6x over 1, that is okay. I will not count off for that. It's just not necessary. Yes. I'm lazy. I don't want to write it. All right. So, guys, questions on a single fraction? Guys, listen. Questions on a single fraction or multiplying? When am I not allowed to take it apart piece by piece when I cancel? When it's attached by a plus or minus. Good. What's the first rule of factoring? First thing in factoring you look for is GCF. For some reason, people suddenly don't remember to look for that. Okay?